All right, let's talk about deep learning. It's a term you hear thrown around everywhere, right? But what is it, really? Well, today, we're not just going to define it, we're going to build it. So, think of us as architects. And our big project? To construct an artificial brain right from scratch. From the very first blueprint, all the way to a finished skyscraper. So this really is the big one, the fundamental challenge. How do you get a machine, which is really just metal and code, to do things that feel, well, human? How do we teach it to spot a friend in a crowd, or get the nuance in a sentence, or even guess what you might do next?
Simple, right? We build it a brain. Now, not a biological one, obviously, but a computational model that's inspired by our own. And just like any huge construction project, we got to start with the master plan.
Yeah, before we can even think about laying a single foundation, we need to zoom out and look at the entire city plan. We have to figure out where our specific project, deep learning, fits into the grand scheme of things.
Okay, first up, you've got the whole city itself, artificial intelligence, or AI. This is the massive, sprawling landscape. It covers pretty much any attempt to make a machine act smart, From a simple chess-playing program all the way to a self-driving car. It's the whole universe.
Now, inside that giant city of AI, there's this really special neighborhood. We call it machine learning. And the buildings here are different. Instead of being built with super rigid, pre-programmed rules, these systems can actually learn and adapt all on their own, just by looking at data.
And that finally brings us to our specific construction site, deep learning. This is kind of like the high-tech downtown district within that machine learning neighborhood. And it's famous for one particular style of architecture, these huge multi-layered structures we call neural networks. This is the skyscraper we're here to build.
So how do you build a skyscraper? Well, you don't start with the whole thing, right? You start with a single brick. And for our artificial brain, that fundamental building block, our brick, is the artificial neuron.
This is our brick and mortar, right here. An artificial neuron is basically just a tiny little math unit. It takes in some information, it weighs how important each piece of that information is, adds it all up, and then it makes a really simple choice. Do I fire off a signal or do I stay quiet? It's just a tiny decision maker. Now, one neuron on its own, not very smart. But when we start organizing them into layers, that's when the magic happens. We start with an input layer, which just takes in the raw data. Then we have one or more of these hidden layers where all the real processing happens. And finally, an output layer gives us the final answer, our prediction, like buy or don't buy. Okay, let's zoom in on the real nuts and bolts, because this is where the learning actually happens. Each of those inputs has something called a weight. Think of it like a volume knob that tells the neuron how much attention to pay to that signal. Then there's a bias, which is kind of like the neuron's default setting. Is it naturally easy or hard to get it to fire? And finally, the activation function is like a bouncer at a club. It looks at the total signal coming in and decides if it's strong enough to get passed on to the next layer. It's this whole combination of adjustable knobs and gates that lets the network learn these incredibly complex patterns.
Okay, so we've laid the foundation. We've got our basic structure. But to get to the deep part of deep learning, we have to start building up. It's time to go from a single-story building to a towering skyscraper.
And this slide just lays it all out perfectly. A shallow network with maybe one hidden layer is great for simpler problems, but a deep network, our skyscraper, has many hidden layers. And this is so cool. The first layer might just learn to see simple things like edges and colors. The next layer up takes those edges and combines them into shapes like a circle or a square. The layer after that might combine those shapes into an eye or a nose, and by the time you get to the top, the network can recognize a complete face. That's the power of depth. But, and this is a big but, that kind of power comes with a price. You need massive amounts of data and some serious computer horsepower.
So that's the key right there. When you hear deep learning, just think deep in layers. That's it. It's that depth that gives these models this incredible, almost magical ability to find patterns in really messy data, all by themselves, without a human having to point them in the right direction.
All right, our skyscraper is built, it's powerful, it's complex, it's pretty impressive. So now, let's take a little tour of the modern world and see what these incredible structures are actually doing out there.
In marketing? Oh, it's a total game changer. It's answering the biggest questions, like which customer is right on the edge of buying something? Who's about to cancel their subscription? Will this new ad we designed actually work? It can even watch a video and automatically tag every single object in it. Wild.
Then you go over to the financial district, and these models are working 24/7. They're spotting tiny, fraudulent transactions in real time that a human would totally miss. They're generating trading signals and deciding credit scores in seconds. They can even read and make sense of mountains of dense financial reports.
And its reach goes everywhere else in a company, too. In HR, it can sift through thousands of resumes in minutes to find the perfect person. And out on the factory floor, it's predicting demand so the shelves stay stocked, and it's using cameras to spot tiny defects on a production line that the human eye would never catch.
I mean, this all sounds pretty amazing, doesn't it? But, any good architect will tell you that with great power comes a great price tag. So before we sign off on this project, we have to do one last inspection and look at the trade-offs.
So here's the bottom line. The huge strength of deep learning is its incredible state-of-the-art accuracy, especially with messy, unstructured stuff like images and text. But the requirements are steep. You need enormous amounts of data, really powerful computers, and sometimes the model can be a black box, which means it gives you this amazingly accurate answer, but it can't tell you how it got there. And that can be a huge problem in fields like medicine or finance, where you absolutely have to justify your decisions. And this is a really important takeaway. You don't build a skyscraper for every single job. That would be insane, right? Sometimes for smaller projects that have neat, clean, structured data, a much simpler blueprint, like an old-school tree-based model, is faster, cheaper, and can be just as good, sometimes even better. It's all about choosing the right tool for the job.
So, there you have it. We started with a simple blueprint, we assembled our neural building blocks, and we built a deep learning skyscraper that is already changing our world. We've seen its power, and we understand its price. So the only real question left is, what are we going to build with it next?